Thank you so much. So, as mentioned, my name is Evangeline, in short, Eva. Hello and welcome to today's webinar. This webinar is part of the CSE's Climate Action webinar series. And today's webinar is titled Weather Shocks and Monetary Policy. Today, presenting this webinar, we have with us Commonwealth alumnus Nicholas Okot. Nicholas is a principal economist at the Central Bank of Uganda. And prior to this, he served as a project assistant and trainee economist with the European Union funded Acholi Trust. I hope I'm pronouncing that correctly, Nicholas, Acholi program in the Office of the Prime Minister, which was also a joint initiative of the Government of Uganda and the European Union to strengthen the service delivery in the Acholi sub-region, which was devastated by civil war for over 2 decades. Nicholas has also served as a board member for the Kulika Uganda, a charity organization, providing scholarships to graduates and supporting farmers to enhance their productivity. Nicholas is a 2015 Commonwealth Scholar from Uganda. He has completed his PhD in economics at the University of Leicester, and today he will be shedding light on his PhD research through his webinar. On behalf of the CSE, I welcome Nicholas. Nicholas, a huge welcome to you, and over to you for your presentation.
Thank you so much, Eva, and thank you everyone for joining us for this webinar today. I'm very happy and delighted to join you in this CSE climate change webinar that has been taking place. And I'm happy to present my work. Of course, as has already been mentioned by Eva, I'm a Commonwealth Scholar from Uganda. I've returned back to Uganda. I send you greetings from Uganda to everybody else listening today and watching us on this webinar. I'm happy to present this work, and before I begin to present the work, I think it would be good for me to give you a small background of how I came to this area. Of course, as Eva has already mentioned, my background is into central banking. Even though I worked in the office of the Prime Minister prior to joining the bank, I've spent a longer period of time working at the central bank. Now, my interest was to work on monetary policy and to see the implication of monetary policy on the economy, and then do research around those areas of monetary policy, and then use modern techniques to actually work on monetary policy. But however, I was actually motivated by the inspiration that I drew out from the Commonwealth development module that we usually conduct when we are Commonwealth scholars at the university. And in one of the modules, we discussed so many development issues. And when I went back to the University of Leicester, I said, how can I add on an aspect of development into my monetary policy? And I looked at weather shocks. At the time, there was limited research available on climate change, despite the fact that the initiative had taken a grounding in the policy arena. You could hardly find publications or empirical evidence that have been working on the areas of climate change. But I still went ahead and said I was going to try to see how I can incorporate climate change into my study and see how climate change could be a useful tool actually to understand the dynamics of the economy, and then how stabilization policies can be used to address the issue of climate change. And it was very nice to work on this subject. A number of initiatives have since grown since 2017, when I was focused on this work. A number of papers kept coming out, and numbers of issues and supporting the entire research. Without wasting much more time, let's go into the actual work of what we've done in this research. So as is mentioned earlier on, this is part of my own research, and it is very important that we look at climate change, because this is one of our chances to actually address the issue of climate change and its challenge on the global economy. I know a lot of attention has already been drawn on the issue of global warming and its impact. The recent meeting at the COP26 in Glasgow has highlighted a number of issues to do with global warming and what we should do to move to less than 2%, sorry, 2 degrees Celsius in terms of global warming. But really, what is the origin of everything? Before I go into the real gist of the economic aspect of it, Now, what do really causes it? And we already know, many of us do know, but it's still good to repeat this for the benefits of everybody. That one, it is attributed to the emission of greenhouse gases, and you know many of them. Carbon dioxide is the leading cause, but the methane and all the other gases. Then, of course, disposal of hazardous waste. In most cases, this happens in the water bodies that do affect the ecological system in the water bodies, and therefore leads to actually climate change and its own events. And then in the developing world, in particular, the issue of population pressure on the environment has actually put a huge impact on the climate change, and is therefore creating global warming and shocks related to those climate change. The impacts are observed in terms of a number of outcomes that we see. It could actually appear in terms of the deterioration of the ozone layer, which is largely caused by the carbon dioxide, which is emitted by our manufacturing plant, by emissions from greenhouses that we work with, and of course combustion in the automobiles that we use for our transport and cooking and so forth. And this has also led to a rise in global temperature, an issue that has been addressed very, very prominently in the last meeting that has been held in Glasgow and still going on. And for the people who live in the polar parts of the planet, it has also led to the melting of the polar glaciers, and it is definitely going to lead to flooding in some areas that are low-lying and could not have flooding in those other parts. And then for the developing world, due to the pressure on the environment, there's been depletion of the forest cover, both for usage and to also create room for agriculture and other human economic activities. In the end, this has led to to issues like drought in many parts of the country, and even drought that pops up from nowhere. And then, of course, in some cases, floods, and areas get flooded because the climate is not really uniformly addressed as it is supposed to be moving in its own original system. Now, in terms of impact, the impact is likely to be higher for lower developing countries. This is because they're highly dependent on climate or nature in their own production system. And this could actually, in the end, lead to a reversal of the gains that you've made over the years in actually poverty eradication. And in the areas of economic activities, it could lead to actually food insecurity, where we have very low supply of food being produced because of climatic conditions not allowing farmers to produce enough food for our planet. And therefore, this could translate into higher food prices. And for those who cannot afford, that would definitely lead to hunger, which we have seen in some cases in the past when we have had long drought and in the periods of the wars. And then for countries that do depend on exports of agricultural commodities, for instance, countries like my own that do depend on the export of coffee, tea, cotton, tobacco, and so forth, their climate change has a huge impact on the productivity and on the output that we realize from some of those crops that are used as exports for the country. And definitely they are also part of the inputs into the industrial processes that we actually have. This will lead to, this will definitely affect the level of economic activity, as farms and households will not have enough activities to do, and also the output would also dwindle, therefore affecting all the other cycles, including credits to the private sector. In terms of the background, I think we'll need to spend some time on the issue of climate change. It has received a very good agenda in the last few months, of course, and this is very timely that we are having this discussion at this point in time. And it is now integrated into the policy agenda of at national level, at regional level, and then of course at the international level that we have just seen in the recent past. One of the earliest that I could see, and which I tried to point out even in my own research, is that of the UN Millennium Development Goal. And in one of the goals, number 7, the UN put up an ambition that we should ensure environmental sustainability by the time the millennium will come to the cutoff point. And the next one, of course, after that revision, the UN Development Goal number 13 still take up that same issue and say we should take urgent action to combat climate change and its impact on the environment, which was still also a very good initiative at the policy level. And this is one of the agendas which are still being implemented, and it's also still being discussed. The Paris Climate Agreement came up with a number of initiatives and a number of rules that are supposed to be implemented, including in the financial sector, items like carbon pricing, and then issues that are that are required to be done so that we can achieve the level of rise in temperature that we desire in order to be in position to combat the impact of the climate change on the global economy. In the financial sector where I work in most time, the issue of the climate change took a gradual step. It has just picked up and is beginning to pick up, and I believe to pick up at a much faster rate, as we'll see as we go on with this presentation. Already, our institutions are trying to prepare for adverse impact on climate change. In particular, lending institution, I look at it in terms of the impact on the productivity of their customers, and therefore the ability of those customers to pay their credits. And then, of course, it has led to the need to design products that are suitable for all types of customers. How do you design credits that are suitable for customers that are trying to address climate change issues, or customers that are likely to have climate change issues? And then, of course, the issue of risk and the pricing of the risk in both ends, and in terms of pricing of subsidies, the finance sector has actually come in a big way. And of course, lately there's also been an adjustment in policies, including, of course, stress testing in both monetary policy and of course in the finance sector stability, to see that climate change risk does not actually translate into financial sector risk as well. In terms of motivation of my study that led to actually this, my study was actually, the main motivation was to try to enhance our knowledge of the impact of climate change on an economy and its implication for the transmission of those shocks to the real economy. However, to get into that depth, we needed to quantify the contribution of climate shocks to aggregate economic fluctuation in an economy. We have a tool that we use to do that, and I will show it at some point in time. And then we also wanted to estimate the persistence of that climate shock on the output or else on the productivity of an economy, and definitely on the relative prices of the goods and services that we actually produce. Having done that, then we want to quantify the impact or evaluate the impact of monetary policy, if monetary policy is supposed to be used as a stabilization tool to mitigate some of the impact of climate change, given that its implication on economic activity could actually lead to a desire by the monetary authorities to actually come in and try to address some of the issues that it can bring into play, for instance, price changes and so forth. Now, it is important to see that we need to address these issues. Why do we need to address them? And for certain set of countries, it is much more desired than others. One of the reasons is that many of the countries, developing countries in particular, are heavily reliant on rain-fed agriculture. They don't have irrigation systems. So agriculture really relies on rainfall. So if rainfall doesn't come, or that's in the case where you have drought, then you have no harvest. And then in the case where there's excessive amount of rainfall, then you have either no harvest or else you have actually totally ruined up crop in the whole system. So a reliable amount of rainfall is actually really necessary, and therefore that's why we actually have an interest in this. Since the economies of these developing countries depend on agriculture, and if agriculture is to rely on rainfall or temperatures, then definitely this country would actually have implications for actually climate shocks. This could affect the livelihood of the residents of such countries, of course, in this case, Uganda, input into the manufacturing system, and then, of course, the exports of goods and services that they would need because they are reliant on agricultural-based output for export purposes. Of course, it also has an implication on supply-side shocks. And in many of these developing countries, supply actually remain a major drivers of inflation, and therefore feed into interest rate and exchange rate as well. Because supply constraint actually immediately creates a rush to actually buy those goods and services, and therefore that creates an environment in which farms and households tend to actually compete for the good, creating inflation in the end. I want to continue to motivate the study by showing you where we are and why it was necessary to actually do this study. If you look at this map carefully, you'll notice that the map shows the climatic zone that we have in Africa. You have the arid areas. For instance, you have the Sahara Desert level there on the upper part of the map. I'm pointing with my mouse. Then you have in the lower part, of course, you have a small area that is covered by this Namib Desert. And then, of course, there's a large part of the savanna savanna environment that covers the tropical rainforest or the Congo Basin rainforest, which is heavily colored in blue here in this case. Now, Uganda is at the frontier of climate change. As you can see, Uganda is the country level in the middle here, and the country, the Lake Victoria. Part of it is taken up by the savanna rainforest, and other aspects are also within the tropical rainforest. I give you a small story. Stories told by my parents when they were much younger was that much of the country was actually still a tropical rainforest when they were growing up. The country had a small population then, about 6 million. Now we have about 43 million people. So that has grown in number. But over the years, the impact of climate change means that the tropical rainforest remain a very small area in the western part of the country, and is receding and going towards the Democratic Republic of Congo, which is the next country to the western side of the country. Much of the area now remains an area that receives some amount of rainfall that looks more or less like the savanna instead of looking like a tropical rainforest that it was before. So the current climatic condition now is a small range of a tropical rainforest that still exists in the southwestern part of the country. Then you have the savanna, which covers much of the country, and then the northeastern part that borders Kenya has become semi-arid in this case. So Uganda is at the frontier of both the heavy climatic change, and therefore there's need to actually assess the impact of climate change on Uganda's economy and the implication of it on the policy changes that Uganda should have. In terms of how I have addressed this study, I wanted to actually first disentangle the economic activities in this country into two. So that since agriculture is a major contributor to the economy, I wanted to split agriculture into one group, and then the other non-agricultural activities into one group. So I broke the economic activities into two categories. And one side is agriculture, one side is non-agriculture, where in agriculture, weather shocks do affect output. So you look at it, if you look at it in terms of how production takes place, is that you have a piece of land, then you have weather, then farms and households do supply labor to that farm, and therefore they should get an output. But then you have weather which is variable. It has its own shocks that moving up and down. For land in this framework, it's easier to make it a little bit fixed in this case. Then labor can also still be varied depending on the availability as well, and then of course in terms of the time frame. And then we look at it in terms of the prices, and then how prices would actually move at a later stage, of course. And then, of course, in the other sector of the economy, I decided that, okay, the other sector will remain normal, like the normal other economy. You can use capital to produce goods and services, and also have some labor input, so you can have innovation, like what we're using now, a computer or something of the kind, or tractor or something of the kind to produce those goods. To help to motivate the whole study, I decided to actually first understand the business cycle dynamics of Uganda, looking at the data to see how the business cycle dynamics move, how does the weather move, how does the output move, and everything else. And then to do that, I also tried to estimate a simple econometric model that is trying to help to understand whether there's a transmission mechanism from weather to actually the real economy, and therefore to prices. And in that case, we could also have an impact of policy on that. So I use what we call in economics the structural vector regressive model, or SVAR. And then later, after motivating it, as I will show you later on, I went ahead to actually estimate a full model that tries to allows me to actually allow many shocks to happen at a multiple point in time. Those of you who are well conversant with a structural vector regressive model would know that in such type of model, shocks happen once at a time, one shock happens at a time. But if you have a situation like climate change, many shocks can happen to the economy at one point in time, and therefore the DSTE provides a good environment to replicate the business cycle, and therefore to also allow all those shocks to happen to the economy at the same time, and therefore to see what policy can do when multiple shocks are hitting the economy at the same time. That motivated my choice for that type of modeling. I want to make it very simple by describing the DSTE in a very simple framework, which is a representative agent model. It runs on a very strong assumption that agents are very rational. We make very rational decisions when we want to actually spend or to actually receive income. It starts from the household, and the household is on your left-hand side. And in that place, we assume that households are really rational. What they do is they supply labor force so that the labor force can be used by the farm, which we'll see a little later on. And they also consume the goods and services that are produced by the farm. And then of course, over time, they own the farm as well. Okay, sorry, they own the farm as well in those models, in this case. Now, to make my model work out very well and to motivate and to see the impact of agriculture shock on Uganda's economy, like I said earlier on, I split the DSG into two sectors of production. So you have production taking place in the agriculture sector, and then you have production taking place in the non-agriculture sector. In the agriculture sector, production takes place with the use of land, which is a fixed kind of resource. And then, of course, you have labor force supplied by the household. And then you have weather. Weather, in this case, we're going to look at rainfall as an input into the agricultural productivity. Because temperature is still fairly moderate and its adjustment is actually quite low. And then in the non-agriculture sector we are using labor and capital to try to ensure production takes place. Now, weather, of course, I've motivated it up here. So weather can be in the form of drought and flood. And in this case, we are going to shock it in terms of drought so that there will be no rainfall in some period in time. Because here is a country which has more or less a fairly good amount of rainfall. So drought is a good shock to actually look at the impact on the economy. For the agricultural sector, we assume that the farmers are a little bit naive, and therefore they are going to be price takers. So price will be set by some sets of farms here, and therefore they will take the price as they set. For the other non-agricultural sector, we assume they are fairly sophisticated. They could be involved in manufacturing or in service sector, and therefore they can set their own prices. To make the model work well for a small country economy like Uganda, we decided to put up some open economic features. So we allow agents or farms and households to import some goods, and also to allow ourselves to export some of the goods that we don't also need in our economy to consumers elsewhere, and therefore generate income or the foreign exchange that is required to actually import the goods that are required. On the left-hand side, I have monetary policy because I want to use monetary policy as a tool to stabilize the economy once you already had a shock in terms of a drought, and see how the implications transmit into the real economy. In this case, monetary policy is working with an interest rate rule, where it decides on the amount of interest rate depending on the direction inflation is taking and the direction the output curve is taking. Of course, if there's a drought, the output might actually come down because of the lower amount of agricultural output, which affects both industries and agriculture directly. So the DSG in this context can be thought of as a system of simultaneous equation that allows you to input in as many shocks as possible, so that you can actually try to estimate the impact of those shocks on the economy. Now, in terms of the findings, now we went ahead and this is a finding based on my structural VAR model. So maybe just before I go into the finding, I give you just a small tip. We put in a number of data set to come in to actually estimate this. We look at about 10 variables that include total output in the economy, agricultural output, prices in the economy, price of agricultural output. We look at items like prices of foreign goods, output in the foreign sector, and then real effective exchange rate, and then things like interest rate in the foreign economy and in the domestic economy. Now, when we input a unit shock to the agriculture sector, and that will mean a unit shock to weather, and that leads to actually drought, and then you see that it decays actually normally and comes downward here. Now, this would initially lead to a pickup in the price of food price inflation or price of agriculture in this case. And overall, because of that pickup or because of that shock in the weather, you see the output of agriculture drops down here because of the drought that has happened, and therefore it will propagate. And if the drought is a temporary one, it gets transitory, it will happen once, and then the agriculture output actually comes back to its normal level, as is shown in this graph on the lower part, which I'm showing with the cursor. Of course, the implication will transmit to the overall GDP of the economy, and the overall GDP also drops because agriculture contributes about 22% of GDP in Uganda directly. But also, like I said earlier on, it also does contribute to GDP directly in terms of the manufacturing sector, and also contributing to some other aspect of the service sector as well. And then, of course, you can also see the impact on the exchange rate because it's also a major export commodity, and therefore the shock in terms of the weather is transmitted into the exchange rate, and the exchange rate actually drops in that point in time. And then, of course, core inflation picks up because now there's low supply, and therefore they need to actually compensate for the loss in supply by competing in the prices, and therefore the prices pick up, and this definitely could actually trigger a series of actually events that could lead to the macroeconomic instability in the entire economy. Now, looking at the output from the DSGE, the output from the DSGE are actually quite multiple, and those who would want to look at it in depth would actually look at one of the working papers that I have, or just search my name and they'll definitely come up, or can actually ask additional questions at a later stage. But I picked the one which I think is the most important for the purpose of this study, actually, and that's the implication of monetary policy shock. If you are to shock monetary policy because you have already had an agricultural shock. So you notice that the monetary policy shock would be a shock on the interest rate, and therefore, because you're using interest rate as a policy instrument, it decays off. It doesn't decay actually very, very slowly. It decays actually very, very fast. This is based on the DSG estimation. Outputs tends to actually pick up. Output falls very, very, very deep, then tries to pick up again gradually, and then comes back actually immediately. Agriculture is interestingly not affected at all by the monetary policy shock. It actually instead of its output declining, its output actually picks up instead. In this case, creating a little bit of confusion on in the entire system of the model. And then, of course, its implication because of the impact on the output. You can see the impact on the core inflation, but the impact on food price inflation seems to be almost really not very easily distinguishable, because it begins from zero, it drops down a bit, and then actually goes up at some point in time. Then monetary policy actually has a little bit of has a limited impact on the stabilization role in agriculture. We actually think, given that we had a small equation of the fiscal policy rule inside the model, I think fiscal policy could actually be more useful. It could actually play a much better role in terms of carbon pricing, in terms of stabilization, and then in terms of actually carbon subsidies, as we'll start actually see a little later on. However, we think actually to enhance agricultural system, and also to enhance our own adaptation to climate change, there's need for structural reform, and therefore structural policies to actually play a much better role. And this could also help us to actually mitigate the impact of climate change on the environment. In the main working paper, we looked at the historical shock decomposition in terms of how has it happened over the entire period of time, and our decomposition shows that actually there's a large impact of weather shock over the long period, over the long horizon that we actually looked at from the year 2000 up to the year 2017. Then, in terms of the forecast variance decomposition, we see that the impact of weather shock is actually quite persistent going outward, and therefore, if it is not addressed, it could actually have a large impact on the economy going forward. To look at it in terms of the policy implication of this study, now the policy implication in terms of the monetary policy, we see direct monetary policy using policy instrument like interest rates have a limited impact on weather shocks, because agriculture does not respond. Instead, it actually creates a little bit of a difficulty. As you may note very well, it is transmitted through the credit channel. So if farmers now are accessing a credit at a very high interest rate, because the monetary policy is being tightened, therefore the farmers cannot also actually produce, as you saw in the other graph on the other side, and therefore that would lead instead to actually a rise instead of actually a drop in that case. But however, we think, as I said earlier on, fiscal policy could play a major role in stabilization given its impact in the very short run. This could come in many forms. It could actually come in form of carbon taxation. Carbon tax and carbon pricing has actually been a very novel area in terms of research in this recent past. And there's been a number of research coming out in terms of actually carbon tax and carbon pricing. But of course, this must also come in tandem with the issue of carbon credits, which should be availed to actually countries that cannot, or else agents that are not emitting, but instead actually helping to address the carbon cycle by maybe planting trees and something of that kind. Then there's also need for targeted public investments in areas that address issues of climate change. Of course, technology provides a very good platform for innovation. For countries that can, or for where water is available, irrigation should be used as a very good use of technology. technological innovation in the industries that are currently emitting a lot of carbon dioxide in the atmosphere. You've heard about industries that are still using coal power, and those that actually use petroleum or diesel power to actually run could actually still be emitting a lot. So if we come up with some innovation that they can work with solar, they can work with windmill, those should be in position, but those could actually be through government financing, which is actually through the fiscal policy. Then innovation in transportation, we currently use jets, we currently use motor vehicles, we use a number of locomotives that use actually petroleum, and therefore they could actually be polluting our own environment. And then lastly, the sustainable and efficient use of energy. So we have energy, we should be in position to use them actually efficiently as well as taking up a well-designed community initiative at the local level so that we can see that climate change and these issues are actually well addressed. There is also a need for international policy coordination, which I already see in terms of climate change and issues to combat the impact of climate change or to adapt ourselves to actually climate change and its own related issues. I note it is important to note that there is no time to actually waste on this issue of climate change. We need to act now to employ all the measures actually to address the lessons that we have learned from the COVID-19 and see whether we can use that type of collaboration to also address the issues of climate change moving forward. My research is having a small impact as well. The impact is likely drawn from a number of angles that I'm trying to look at. In terms of our current set of work, we're trying to influence people in the central banking industry to see that they also incorporate climate change as part of the monetary policy equation and also to address monetary policy within the context of climate change. So we should draw on and integrate climate change as part of our decision-making processes and see how they can actually make them actually work. And this could also come in the areas of regulation, as you may well know that in most cases, central banks are actually regulators of financial sectors, especially what depository corporation or banks in many countries as well. And then, of course, I also note that there's still need for more work, and more work is being done. I'm presenting an older paper. There are much newer paper I already worked on to actually try to address the issue of climate change. In particular, cross-country analysis should actually be more useful, or analysis that uses a panel set of data or a group of countries would be more useful because climate change cannot be distilled in terms of only one country. But one major challenge remains in that area, and that's the issue of information. Data is still very limited. I know the World Bank has put up a very good platform where you can actually have a look at lots of data, but data is still very limited and there's need for more data in order to address the issue of climate change and also to enhance the issue of forecasting. This will definitely be useful for the financial sector in terms of financial markets, having data so that traders can trade on those issues. And then, of course, also pricing of risk and then of modeling of risk for the insurance firms and companies to take up those kind of risks. Locally, in my own community, I have taken the initiative to also promote awareness among my own community. I talk about climate change quite often when I get the chance to talk to my people about climate change. We also have an initiative for tree planting to try to enhance the level of greening of the environment in the locality where I come from. And that I believe is going to go a long way in trying to address the issue of climate change as we plant fruit trees. That could also be useful for us to actually consume as actually food in itself. Finally, as I come to the end of this presentation, I want to give a special thanks to the Commonwealth for funding my studies at the University of Leicester. They funded this research and indirectly, of course, by funding my PhD in economics at the University of Leicester. The University of Leicester had a first-class facility for me to do my own research, access to a number of journal papers, access to data that I needed to do the analysis. And then I also wanted to thank the CSG for the Commonwealth, for the development module that you've been doing. They have been very instrumental, as I said earlier on, in shaping this chapter of my thesis on weather shocks and identification of development challenges that do affect developing countries, and then the issue of climate change and actually financing in itself. I believe this will go a long way to help us discuss the issue of climate change at the level and its implication on financing, and also at the level of the policy level in terms of stabilization. Thank you very much.
Thank you so much, Nicholas, for your brilliant presentation. I will give you a few seconds before we open the Q&A session. But really, your presentation was so insightful, and I'm sure the attendees would agree with me on that as well. You provided information on your PhD research study, mainly focusing on the effects of climate change on the economy, with special focus on Uganda, your home country. You also explained the DGSE model and spoke about the impacts of your research at various levels within your local community and nationally as well. So thank you for shedding light on your presentation. I would now like to invite attendees to ask your questions for the speaker. You can do that by sending in your questions via the chat box. Equally, if you are working in a similar field or if you are conducting a research study on a similar theme, please feel free to share your thoughts. You can send that in the chat box as well. Nicholas, if you're ready, we do have a couple of questions that the attendees have shared in advance to the webinar. So if you're ready, I can bring them up and share them with you.
Yes, I'm ready. We can start with the questions.
Wonderful, thank you. So the first question is, how to measure weather shocks with the monetary value?
Thank you so much for that question. And I think the question tries to address two items at the same time. First, weather shocks is measured separate from the monetary variable. And maybe to explain this, I know you can't get everything from the slide. In my own study, we measured weather shock using an index. The index, I created it based on the data on precipitation, or the amount of moisture in the air that is usually compiled by the weather agencies, and they are available on a monthly basis. But because I was working with output, I needed to actually have them on a quarterly basis as well. So I created that index, and that index is actually the one that actually creates weather shocks. So when you use it, you use the index based on actually a 12-month moving average, then it creates for you a business cycle dynamics that actually replicates the cycle, how weather happens in this part of the world. If I may give you information in my country, in this context, we do have two rainy seasons. There's one that begin from March to June. Then there's a small drought for about a month in the month of July. Then from August up to around November, this time, we do have a good amount of rainfall. So then the index that I created actually do help to actually mimic the way the weather pattern actually behaves over the entire cycle on a year-on-year basis. And therefore, in terms of quarters, those are over the next two sets of quarters. Now, in terms of the monetary policy measures, monetary policy is very easy to measure. The success is measured by prices. So they are looking at how prices actually have moved. So the price indices that they use are the consumer price index in most cases, but there are also other baseline indices like the producer price indexes and so forth. But if you don't want to use that, inflation can also exchange rate can also tell you how you are faring in terms of your currency with the rest of the world, and they definitely feel that into your own prices. So all sets of prices, including interest rate and so forth, actually the measures that we have used to measure monetary policy. So they have fairly different measures, but the interesting thing about both of them is they affect output, or they affect the real economy, they affect the production of goods and services. So weather shock affect the agricultural output, but if you also do prices in terms of inflation, in terms of interest rate, in terms of exchange rate, they also do affect the real economy in terms of the behaviors of the agents. Thank you.
Great response to the question. And to start off our Q&A session, we have a couple of questions coming in through the chat box. The first question is from Roy. First of all, excellent presentation. Can these strategies from your work be utilized as a framework in other parts of the world, for example, in the Eastern Caribbean? And to follow that question, I would also like to add positive response that we've received from one of our attendees who have mentioned that your webinar was very instructive, and many of these measures are applicable to several countries that drives to this extent. So over to you, Nicholas. Do you want me to repeat the question?
I think it's fine. I got the question. I think the approach is very good. The approach is quite extensive. For those of you, those who have time to search my name and look at the thesis itself, can actually download it and look at. It's a full length of about 60, 70 pages, and it can be used for any country. So you can apply it to any country, and then you can see the implication of weather shocks. The only major work that you definitely need to do is to try to work on the index. So you have to work carefully. You have to study that area carefully to see that you actually can calibrate that index very well and get a good index that replicates the cycle of weather or less climate shocks in that part of the world that you're working with. But like I said during the presentation, towards the end, it's important to do this type of study for a set of countries, because climate shock doesn't affect one country at one point in time. It affects a group of countries because it affects a large set of areas, because climatic conditions affect a large set of areas. It will be good to collect a set of countries from a large area and then try to estimate this type of model. And I'm trying to work on that. And once they're out, they will definitely be published, and therefore if you keep on searching my name, you'll find them out there. For the VAR part, they're already working. So I'll have a panel VAR, which panel means a set of many other variables, many other countries, sorry. And I'm working with the panel VAR, and the estimates are coming. And then I'm trying to see how I can make the DSGE actually work for many countries at one go. So because what has been happening is people run the DSGE for individual countries and then try to compare them, how each of the countries are actually what perform. So what I want to do is to extend it so that it is possible for it to work for many countries. But for individual countries, yes, it is still possible and can work. Or for region, if you collect data for the region and treat the region as one unit, it will definitely work. Thank you.
Wonderful. The next question is around the data. How did you get the data for weather shocks with GDP in a country level?
Okay, thank you so much for that question. Actually, I think I should have thanked the other person earlier on for the compliments, which I think I forgot. I thought I was thanking him at the end of that remark. But yes, yeah, the data is available, and as researchers, you have to look for data from a range of sources, and you need to also compare them. Now, for the weather part, the precipitation data is available from the World Bank. Actually, recently I've been to the World Bank while I'm doing the extension of the work, and I realized that they've actually created a very good site. If you type the World Bank weather, they'll take you to the last site, and where you can trace your own country. And I was actually looking through my country. They put up some reading and some sets of data. Some countries do have some more information than others, depending on the availability of information from the country level. So data is available at that level. Now, data for aspects like output, they are normally available from the National Statistics Office, the NSO in the UK, for instance, and many other statistics agencies, including, of course, the IMF can also give you some sets of data on output for each of those countries. The IFS, or the International Financial Reporting System, provides some sets of data. So what I did was to gather data first from the original source, which is my source country, then try to compare them with the data which has already been calibrated and actually is now being disseminated by the other multilateral agencies like the World Bank and the IMF. So the World Bank has a very useful database, which is called the World Development Indicators, where you can get all sets of data on your own economy, and that can be useful for your study as well. But it's good to cross-check the data with other sources of data so that you see that they are speaking to one another. Thank you.
Wonderful. The next question from our list is, can the DSGE model be applied broadly across the agri sector?
Yes, the DSGE can be broadly applied across the agricultural sector, but if I'm to tell you the history of the DSGE, earlier on I just called it a rational agent model. The way they were originally set up was were set up for rational agents, and they were more structured for a system of an industrialized economy, where agents go and work in the factory, then they come back home, then the factories make profit, then they provide the return to those agents, or they make the good and sell the goods to those agents. But over time, economists have been working around the clock, and they have tried to relax some of those assumptions to allow the DSGE to also work for actually developing economies, and also to take account of aspects like, in this case, agriculture shocks as well, and weather shocks. So we could now come up with a DSGE which is fairly modified, while the agent level is still almost like in the original DSGE. Agents household have to go and work in some farm, and then they'll come back home, and then they'll buy the goods from that same farm. But in the production section of that model, then we now modified it. Instead of using capital, we're now using land, and we're using output from weather, in this case rainfall. And therefore labor remains actually constant, like in most other DSGE models. There are very many variants of the DSGE. It is a matter of modifying it to suit what type of study that you want it to do. It can be modified to actually work purely for the agriculture sector. I've not seen one, but it can work. Thank you.
Thank you for sharing that information, Nicholas. The next question, if I do understand that correctly, it's around engineers or individuals who are engineers understanding finance. So can you shed light on or discuss statistical models that are good for use for climate change, or for professionals who are understanding climate change?
I think that's a very good question. Now, in the first instance, the disciplines look very, very different. You find engineers with a lot of calculations. Fortunately, the economists have also tried to work their way and have a lot of calculations. But I think to understand finance, you are better off first to begin by simple analysis. And in most cases, the simple analysis can be just by graphing the historical, what has been happening in the past before. So even if you look at agricultural output, how has it performed in the history? So if you're looking at your country from the 1950s to 2020, how has agriculture been performing in terms of its output, or in terms of the number of people it is employing? So that's a very simple basic set of analysis. You can also use averages to look at between periods and see how they have moved. But in particular for models like the VAR model, those ones were built by economists to try to see the relationship between variables, how variables relate, or how they co-move together. And then what we do in most of those models is we try to strip them down of their trend, so that we can see they're moving without them having a trend. So they're now moving without having a trend, and you see them. And for the purposes of DSGE and for models that are linked to DSGE, what we do is we use them in terms of cycles. So we remove them and make them move in terms of the business cycle, so that they're moving gradually in a nice way. But the attempt with the vector autoregressive model is to try to see a core movement as well, and to see the movement jointly. And then when the shock happens, how does the RDB respond to those shocks? Now for the DSGE also, you try to strip them down, and then you make them move in form of business cycle movement. So there's an element of movement in the business cycle. But the beauty with it is allowing you to see the impact of shocks on many of those variables at the same time. So then you can see the impact that are moving on. In terms of DSGE and engineering, or DSGE and finance, let's start with engineering first before we move to finance. In terms of DSGE and engineering, actually DSGE has borrowed a lot, or growth theory has borrowed a lot from engineering. There are a number of issues that we do, a number of calculations that are actually based. So for instance, one of the assumptions that we have for agents or economic agents, that they optimize actually what utility. That means they actually reach some maximum level. So you have this idea of maximum, at the turning point, the differential of everything is zero. So the thing comes up to zero. So you use actually the usual differential calculus that we use in engineering for doing that, and that gives them a lot of relationship. And when you're studying it and you're studying some engineering book, you actually find that actually the DSGE actually draws a lot from the engineering. If you go to the price setting method, it's also drawing a lot from the engineering calculation and how prices are set in a sticky way. There are also lots of aspects of engineering. The aspect of depreciation of capital, which is actually available in the area of production function, also draws fairly heavily from engineering as well. In terms of finance, it has evolved. It is now being used a lot in finance. One of its major setbacks was to try to use business cycle or growth cycles, and that depends on GDP. In many countries, GDP only comes out once in a quarter. Now, financial markets are very rapid. Things can happen within a few minutes, and they can have implications. So they are now being modified, and there are a few assumptions that are being made, such that you can have what is that actually, despite the fact that some variables are moving and on a quarterly basis, you can take account of variables that are moving very fast, like on a daily or even on an hourly basis, which are usually useful in the financial markets. Yeah, but the calculations, yes, they do really come from the engineering industry, and they are quite similar to that. And the math books are almost the same. Thank you.
Great. Thank you so much for your in-depth response to the question. I'm sure the attendees have found it useful for the questions that, for the responses that you've just responded to the questions that have come through. With this, since we do not have any further questions, I would like to end the Q&A session. But before ending the webinar, I would like to extend a huge word of thanks to Nicholas, our speaker. Thank you so much for presenting your webinar topic as part of the CSE's Climate Action webinar series, and for giving information about your PhD research study. I'm sure the attendees will have found it very useful. And if there are any questions, if you would like to connect with Nicholas, please feel free to do so via LinkedIn. Nicholas is more than happy to connect with you all, especially if you have any further questions or would like to take the discussions further. Please do connect with Nicholas on LinkedIn. As mentioned, the webinar will also be shared on the CSE's YouTube channel. So do check out our climate action playlist on YouTube for all the webinars as part of this series. For all the attendees who have joined us, thank you so much for attending.